So, you want to build a world-class AI model? Well, you're going to need world-class data. It's pretty much that simple. But have you ever stopped to think about where that data actually comes from? How you take the raw, messy, chaotic internet and turn it into something pure, something powerful? Today, we're going to pull back the curtain on exactly that process. Think of it like refining digital gold.
Here's the game plan. We're going to walk through the entire data refinery. We'll start with the raw material, the internet itself. Then we'll look at the basic cleaning pipeline, add a pretty amazing secret sauce using AI, and then, of course, we'll check the results to see if it all paid off. Finally, we'll land on the big recommendation.
All right, first things first. To build anything great, you have to understand your raw materials. And in our case, that material is a gigantic, sprawling dataset called Common Crawl.
And when I say gigantic, I am not kidding. Common Crawl is almost impossibly huge. We're talking about nearly 100 snapshots of the internet taken since 2013, adding up to about 20 trillion tokens. Now, what's a token? Just think of it as a word or sometimes part of a word. So yeah, it's an absolutely astronomical amount of text. It is the entire digital ocean all in one place.
But here's the catch, right? Bigger is definitely not always better. Trying to train a sophisticated AI on this raw, unfiltered data? That's kind of like trying to fuel a Formula One car with crude oil. It's just a mess. It's full of junk, repetitive nonsense, and low-quality stuff that will seriously drag down your model's performance.
Now, lots of brilliant people have tried to clean this up. You've probably heard of some of these famous data sets like C4 from Google or Refined Web, which was the fuel for the Falcon models. But recently, when models like Meta's Llama 3 and Microsoft's Phi 3 came out, their reports kind of hinted that they were doing something different, a whole new level of filtering that was giving them these incredible results.
Okay, so let's move to the first stage of our refinery. This is the basic pipeline, where we take that messy crude oil from Common Crawl and start turning it into something we can actually use.
Think of this as a multi-stage filter. First, you gotta crack open the raw web files and just pull out the text. Then, the real cleanup begins. You filter out bad websites, focus in on just English language text, and then run a whole battery of quality checks to get rid of the obvious junk. And finally, you hit it with a super important step, deduplication.
Now, these quality filters, these are really the workhorses of the whole operation. They use what are called heuristics, which are basically just smart rules of thumb to find and toss out bad documents. They're looking for stuff like, is this text just repeating the same phrase over and over? Is the formatting all weird? Are there too many sentences that don't end with punctuation? It's a really systematic way of skimming the junk right off the top.
Okay, now for that crucial step I mentioned, deduplication. You absolutely do not want your model seeing the same text thousands of times. But, and this is where it gets really interesting, the team building this new FineWeb dataset found something totally counterintuitive about the best way to do it.
Check this out, because this is wild. This graph tells the whole story. The orange line climbing up, that's the performance you get when you remove duplicates within each separate snapshot of the web. Performance gets better. But look at the green line. That's what happens when you remove duplicates across all the snapshots from all the different years. Performance actually goes down. So what does that mean? It means a little bit of repetition over time is actually a good thing. It's a signal that shows which ideas and topics stay important and relevant year after year.
All right, so we've run our data through the basic pipeline. We've got something pretty good now, maybe even great. But how do we make it truly exceptional? You know, the kind of data that can power a model like Llama 3.
This is exactly where those simple rules start to break down. I mean, a simple filter is great for catching typos, but it has no way of judging something like educational value. How do you teach a set of rules to tell the difference between a dense, informative article and a page of complete and utter nonsense? You can't.
And the solution? Well, it's pretty revolutionary. You use a powerful AI to be your quality control expert. The FineWeb team decided to use Llama 370B, one of the best models out there, to literally grade every single document on a scale of 0 to 5 for how useful and educational it was.
But there was a tiny problem. Okay, not tiny at all. It was a massive $10 million problem. To use a beast of a model like Llama 3 to score all 20 trillion tokens from Common Crawl, yeah, that would cost a fortune. It was totally out of reach for pretty much everyone.
So they came up with this incredibly smart two-step workaround. It's just genius. First, they paid the master, that's the big, expensive Llama 3 model, to grade a small but diverse sample of about 500,000 documents. Then, they took those graded examples and used them to train a much smaller, way more efficient student model.
This little student model learned to mimic the master's judgments perfectly, but it could do the job at a massive scale for a tiny fraction of the cost. So clever.
So you have to ask, right? Did this super complex, multi-stage refining process with an AI grading other AIs, did it actually pay off? Let's take a look at the performance. And, oh boy, did it pay off. The results just speak for themselves. This graph is the final proof. You see that pink line? The one that is just soaring above everything else. That's FineWeb Edu. That's the dataset created using this exact method. It's not just a little bit better. It is decisively, overwhelmingly superior to every other public dataset out there.
This is fantastic news, especially for the open source community. So what's the big takeaway from all this? What does it mean for you, for developers, for researchers, for anyone out there trying to build the next big thing in AI?
Well, the research makes the final recommendation crystal clear. For the absolute best performance, you don't need to train on a decade of internet history. You just need the best part of it, the most recent web snapshot, filtered for the highest quality by that smart AI grader.
Using this approach gives you the highest octane fuel for your model. You get rid of the outdated information and all the noise from older web data, which means your training is more efficient and way more effective. And that matters because, at the end of the day, better data is simply the fastest, most direct route to building smarter, more capable AI, period.
So this isn't just some academic paper. This is the recipe. The open source blueprint for creating the world's best AI training data is now out there for everyone. The question is no longer how to make the data. The question is, what amazing things are we all going to build with it now?